So I've been donating blood for quite some time actually, and I was curious to see, are there any patterns in my blood? So I set on a journey to discover if there are any patterns. So this is the result that I come up with. This is the software that I've written. And one interesting thing that really stood out was the connection, let's call it, the relationship between lymphocytes. Let's see if I can find it here. Of course, this is just the first version. The user experience hopefully is going to improve a lot. Okay, so this is the really that stood out the most, was a negative correlation between neutrophils and lymphocytes. So what this means is, as you can see, it's almost a perfect, almost -1, which indicates a perfect linear, a perfect negative linear relationship between the neutrophils and lymphocytes. What this means is one increases and the other decreases. So one increases, the other decreases, or the other way around. Okay? So this is it's kind of fascinating, because I would have never been able to understand this just by looking at the paper of the results that they gave me from the laboratory. And so this was pretty much the most astonishing, and I'm really curious to continue this investigation and to see what's the relationship between neutrophils and lymphocytes in the context of kind of predicting disease or blood disease, or just now I'm putting it out there really, but I'm really curious to see the applications of this. Okay, other interesting things that I find out here, for example, between the blood count and the hematocrit. So of course, the more the dots are, the closer the dots are to the line, the more it indicates that there is some kind of pattern or relationship. So for example here, now here is really, really interesting, between blood count and cholesterol. What this means is that now since it's a positive 0.86, which is very close to 1, it means that as blood count increases, so does cholesterol. Now, I'm really curious to put into the frame of an expert all this insights and see if this is actually accurate in their experience. But this is honestly the part that I'm missing, because I'm not an expert in this field. It's not my field, biology or chemistry, natural science, etc. It's not my field. So I'm really interested to see the feedback of an expert, which doesn't necessarily mean that one is connected to the other, because this might even provide insights to an expert which could have never guessed this. So for example, hemoglobin and hematocrit. So let's go a little bit in the technical stuff. This is going to be a little bit more in the technical stuff. So I've used Python. You can see here as a programming language. So here I've done a lot of data cleaning, because I wanted to make sure that regardless of what the user types, for example, blood type, sorry, these are the columns, the features. Blood type, for example, this one here, it's too long. I want to find a way to have one predictable standardized column that I can invoke and I can call in my program without having to rely on all these kinds of different user inputs. Here, this is the uncleaned data set. And this is, let's see if I can read here. This is the streamlined clean data set. So you can see these are much more standardized. So I can know exactly that this is white blood count, this is blood count, hemoglobin, etc. And I can use this. Furthermore, these are all numerical, specifically float values. And this allows me to know exactly how to treat them, and how to and specifically I can use them to create scatter plots and I can use them, create all kinds of stuff that of course I cannot do with other kinds of data, for example, categorical data. So these are all numericals, which is what most blood values are made out of anyways. Okay, so here, but the problem is, when I started to plot the first graphs, the first charts, I was like, okay, and even just by looking at data, I was wondering, how I want to know immediately, is this low, high, and by how much is it low or high from the standard scale, from the reference scale that is right here. So this is the reference scale. Okay, so for example, white blood count, we have these are actually used from our laboratory, and I've just typed them here, 3.7, 10, etc. So these are the minimum and maximum. Now, of course, for each and every value, they differ. For example, neutrophils have a minimum of, with a percentage measure, they have a minimum of 40 and a maximum of 70. Lymphocytes 20, 40. Eosinophils from 0, etc. So, how do I know immediately that how close or how distant it is on a scale from 0 to 100, or in better scale from 0 to 1, so I can intuitively understand how close or how distant it is? Okay, so here I've scaled all the data frame using this scaling algorithm. And here, this is the scaling algorithm. It accepts X range. X range is the scale, the range of X, which is, in this case, X is the value of blood count, let's say 4, and X range is 3.7 and 10. So the question is, how much is 4 on how much is 4x on a scale from 3.7 to 10 to a scale from 0 to 1, which is the default scale here. So this is this is the algorithm that does that, and here it's the other part of the program that computes all of this for each and every value. As you can see, there is a lambda function, which is basically applying this to every value. And so this is the scaled data frame. So basically what this means is that we can immediately say, okay, for the neutrophils, minus 13 or 900, this means that it's a minus 13. So which means that this neutrophil value is minus 13 distant from the minimum value of neutrophils, etc., etc. So for example, this is 155%, that is 55% higher than the recommended value. Or you could also say that on a scale from 0 to 100, it's 155. So this gives you immediately, okay, wow, this is very high, because it's much more than the recommended value. In fact, here, as you can see here, there is the relationship I was talking about earlier. It's very interesting that roughly, if you add this neutrophil and lymphocytes, if you add them up, roughly they're equal to 1, very, very roughly. For example, this is like 1.2, this is 1.2, again, almost roughly, this is 1.3, this is 1.10, this is see, this is 1, this is 1.1, and this is 1, this is pretty much 1. So this is like the discovery that also is strengthened by as I was showing earlier, by the neutrophils and lymphocytes. One decreases, the other increases, or vice versa. So I scaled this because I wanted to see, not only I see from with my eye, but also because it's easier just to compute values, and it's just easier to compute, to have everything scaled from 0 to 1. So this is, of course, the user experience is going to improve, hopefully. Okay, and here I have plotted our regression line. So that's it. With this software, I hope to be able to apply it. I'm really fascinated by the applications of this, and see where this can go. I have in mind to, for example, to take a picture. You take a picture, you upload it, and immediately the program extracts the blood values, everything extracts it right from the picture, so that you don't have to type everything in. Because for now, the program relies on 3 things: the blood tests, so the actual values, which of course you need; the components map, which maps the short component to the long version of it. So, for example, white blood count is white blood count, etc. And then the reference scale, which of course is how you know that a blood value is normal or not, or within the range or not. And see, for now, I'm really excited with this project. I'm really curious as my technical skills advance. So should also the advancement, the advancement of this. So that's the advancement of this program. Thank you so much for watching. And if you have questions, if you have any feedback, because I'm looking for feedback, specific from people in this field, to improve it, to have more domain knowledge, more specific, and to improve it, and to hopefully do something good for humanity. Thanks so much, and let me know on LinkedIn, on Facebook, on my social media. Let me know feedback, questions, curiosity. Everything is welcome, as long as it's relevant and questions. Thank you so much, and see you next one.